Chaos theory, the butterfly effect, the weight of invisibility. This is a true story. The events narrated here are not the product of a conspiracy theory or a work of science fiction, but rather the chronicle of one of the costliest and most fatal eras in human space exploration. Every technical detail, every administrative decision, and every second described in this narrative is based on the official reports of the Columbia Accident Investigation Board, CABE. What you are about to read is definitive proof that the butterfly effect is not just an abstract mathematical concept, but a law of nature that can dictate the fate of heroes and the collapse of technological empires. The weight of invisibility. 7 astronauts, 16 days in space, 82 seconds to disaster. On January 16, 2003, the world watched another routine launch of the Space Shuttle Columbia. What no one knew, not even the crew smiling for the cameras, was that the mission had already ended just a minute and a half after liftoff. A piece of insulating foam, lighter than a basketball, broke off from the external tank. Anywhere else, it would have been a harmless piece of debris. In the vacuum of hypersonic acceleration, it became an invisible death sentence. While NASA debated in conference rooms whether it was worth investigating the minor incident, the relentless physics of the universe was already setting the stage for a catastrophic disintegration in broad daylight, right before the eyes of millions. This is not just a story about a spacecraft that fell. It is a lesson in how human arrogance and contempt for small details can turn the pinnacle of intelligence into a rain of debris. Prepare to understand how the flapping wings of a foam butterfly tore through the sky and changed the course of space history forever. Imagine a machine composed of over 2 million moving parts, the apex of human engineering, capable of traveling at 17,000 miles per hour. Now, imagine a piece of insulating foam, weighing less than 2 pounds, something you could easily hold with one hand. In the world of ordinary physics, these two things should never destroy each other. But in chaos theory, under the extreme conditions of space, the butterfly flapped its wings on January 16, 2003, and the hurricane arrived 16 days later, tearing through the Texas sky. Launch day for mission STS-107 was clear at the Kennedy Space Center. The Space Shuttle, Columbia, the first of the fleet, the veteran, was on the pad. 7 hearts beat in unison inside the cabin. Rick Husband, Willie McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, and Ilan Ramon. They were not just astronauts. They were symbols of international and scientific cooperation. The clock hit 0, and the solid rocket boosters roared, shattering the silence of Florida. Just 82 seconds after liftoff, the butterfly acted. A piece of polyurethane foam, used to insulate the external fuel tank and prevent ice formation, broke away. It was small, light, almost insignificant against the magnitude of the 15-story tank. However, Columbia was accelerating at hypersonic speeds. At that moment, the foam was no longer just foam. It became a projectile, traveling at over 500 miles per hour relative to the shuttle's left wing. The impact was invisible to the crew. They felt the normal vibration of the launch, heard the roar of the engines, but they did not see the exact moment that piece of insulation pierced the wing's leading edge, made of reinforced carbon-carbon. In NASA's analysis offices the following day, launch footage was reviewed. The impact was detected. A group of engineers, feeling a chill down their spines, began to question the damage. They knew the wing was the thermal shield that protected the ship on its way home. They requested spy satellite imagery from the Department of Defense to see the hole up close. They begged for a visual inspection. But here, the butterfly effect moved from the field of physics into the field of organizational psychology. Mission management, accustomed to seeing small pieces of foam break off on previous flights without serious consequences, minimized the risk. They called the event a routine anomaly. The official management response was a dry blow to safety. The foam was too light to cause structural damage. And even if there were damage, nothing could be done in orbit anyway. This decision, made in an air-conditioned meeting room, sealed the fate of 7 human beings 250 miles above the Earth. For 16 days, Columbia floated in the void. The astronauts performed 80 scientific experiments. They laughed, spoke with their families, and looked through the window at the blue beauty of the planet. They were in a bubble of ignorance protected by the vacuum. While on NASA's computers, the countdown to tragedy had already begun. February 1st, 2003, arrived. Re-entry into the atmosphere is one of the most violent moments of any space mission. The ship hits the upper layers of the atmosphere at a precise angle. If it's too steep, it burns up. If it's too shallow, it bounces back into space. Columbia began its descent over the Pacific Ocean. As the air density increased, friction turned kinetic energy into extreme heat. Plasma, a superheated gas at over 3,000 degrees Fahrenheit, began to envelop the ship. Under normal conditions, the wing's carbon shield would repel this heat. But the hole left by the foam, 82 seconds after launch, was now a portal for death. The superheated plasma found its way into the left wing. It didn't just hit the surface. It penetrated like an industrial blowtorch, melting the aluminum beams that supported the wing's structure. Sensors began to fail. First, the left tire temperature sensors went offline. Then, the pressure sensors. In mission control in Houston, Jeff Kling, the maintenance officer, noticed the strange readings. "We're losing tire pressure data on the left side," he reported with a professional calm that would soon be replaced by shock. Inside Columbia's cabin, Rick Husband received the message from Houston. He tried to respond. "Roger, bah," and then silence. Communication was cut abruptly. By then, Columbia's left wing was disintegrating from the inside out. The aerodynamic drag became unbearable. The onboard computer fought bravely, firing maneuver thrusters to try and keep the ship stable. But the physical structure no longer existed. The wing broke off. Columbia, traveling at 18 times the speed of sound, began to spin violently. The G-forces went beyond any human or mechanical capacity for endurance. In seconds, the veteran of space disintegrated into a rain of debris over Texas. People on the ground looked up, expecting to see the white streak of a glorious land. Instead, they saw smoke trails, as if a star were breaking into 1,000 pieces in broad daylight. The sound of explosions echoed for hundreds of miles. In Houston, Flight Director Leroy Kane gave the somberest order of his career: "Lock the doors. No one leaves the room. Secure all data." He knew. The world knew. 7 families waiting on the runway in Florida looked at the blue, empty sky, where only silence answered their cries. Columbia's butterfly effect didn't stop with the destruction of the ship. It caused a shockwave that changed history. The entire space shuttle fleet was grounded for over 2 years. Thousands of jobs were affected. Billions of dollars were spent on the investigation and safety modifications. NASA was forced to face a bitter truth. Its culture of ignoring small problems led to its greatest failure. The final investigation report proved, through laboratory tests, that the piece of foam, when fired at high speed, pierced the wing as if it were made of cardboard. The evidence was irrefutable. In the long run, the disaster accelerated the retirement of the space shuttles in 2011. It paved the way for the rise of private companies like SpaceX, as the American government realized the old model was too dangerous and expensive. A small piece of thermal insulation changed the global space launch trade, altered the geopolitics of the International Space Station, and transformed how humanity views technological risk. Every time we look at the stars and see a light crossing the sky, we must remember Mission STS-21. It is the ultimate reminder that we live in a connected system. In space, there is no small error. There is no routine anomaly. The universe does not forgive neglect of detail. The piece of foam that fell in 82 seconds was the cause. The end of a billion-dollar program and the loss of 7 heroes was the effect. Chaos doesn't need a massive explosion to start. It only needs someone, somewhere, to decide that a small piece of foam isn't important enough to check. Today, the remains of Columbia are kept in a sealed room at the Kennedy Space Center, not as trash, but as an eternal memorial to vigilance. They serve to remind every new engineer that the butterfly is always flapping its wings. and that our job, as protectors of human progress, is to ensure those wing beats don't turn into tragedies that tear through the sky. Columbia taught us that life is a delicate balance between the greatness of our dreams and the minuteness of our care. And that, in the end, everything is connected. Every part, every decision, every second, everything. The Columbia disaster is documentary proof that chaos theory is the most absolute law of the universe. A complex system is only as strong as its weakest link. And sometimes, the weakest link is a piece of foam everyone thought was too light to matter. The stories of Ricardo in Snow Polo or Matthews in Curitiba are useful fictions, but the story of Columbia is the cold, hard reality. It shows us that the butterfly effect is not just about what happens, but about what we fail to avoid. May the memory of those 7 astronauts always remind us that tomorrow is built on the details of today.